What does it feel like? To find a messenger from another star system? On December 28, 2019, the Atlas survey, a robotic system scanning the sky, captured a faint, unremarkable smudge of light.
It was logged as Comet C/2019 Y4.
Then, it started brightening.
It began to brighten faster than any comet on its trajectory should have. It was on track to become a spectacular naked-eye object. But as astronomers around the world turned their instruments, the data they collected didn't make sense.
The object's behavior was erratic. Its chemical signature was strange.
This was not just another rock from our own Oort cloud.
This was an anomaly.
It was soon redesignated 3I/Atlas.
The I stands for interstellar, the third one ever identified.
But this visitor wasn't just passing through. It was falling apart. And
the investigation had begun.
So, where did it come from?
This is the first question our 3D models are built to answer.
In our solar system, objects orbit the sun on elliptical paths.
They are bound by gravity. They are part of the family. A comet from our Oort cloud, for example, travels a long, slow ellipse.
When we plotted the observed data for 3I/Atlas,
the model didn't work.
The trajectory was wrong. The curve didn't close. The data pointed to one conclusion.
the object had a hyperbolic trajectory, an open-ended curve, meaning it came from...
This was the first truth, the I in its name.
It was only the third such object ever confirmed.
The first, Oumuamua, was a strange, rocky cigar. The second, 2I/Borisov, looked and behaved just like one of our own comets. 3I Atlas was neither. It looked like a comet. Its origin was confirmed. It was an alien artifact.
It's not of intelligence, but of geology. A piece of another world.
And as it approached its perihelion, its closest pass to our sun,
It began to send out clues. This is where the real investigation begins. Because the first truth, its origin,
why was it falling apart?
Just stop. And what was it made of? The simple answer of its origin only opened the door to a series of 7 distinct anomalies. That defy explanation.
This is the heart of the investigation.
We have an interstellar object. We know it's not from here. But what is it? What was it made of? To find out, we don't look at the object itself. We look at the clues it left behind as it died. There are 7. Clue number 1. The light curve.
A comet's brightness is a function of its distance from the sun.
As it gets closer, solar energy heats its icy nucleus. The ice turns directly to gas, releasing dust. This cloud is the coma. This process is predictable. It's governed by the laws of thermodynamics. We have models for it.
3I/Atlas shattered those models. In March 2020, as it crossed the orbit of Mars,
It was on track to become a spectacular, naked-eye object.
Astronomers prepared for the show of a lifetime.
and then it just stopped.
The brightening stalled, it reversed, and the comet began to fade. Rapidly.
This wasn't a gentle dimming. This was a catastrophic, systemic failure.
What was going on? Clue number 2, the fragmentation.
The answer to the fading came quickly.
The Hubble Space Telescope was pointed at the object, and it saw that 3I/Atlas had disintegrated. But again, the timing was completely wrong.
Comets are fragile. They often break apart.
But this usually happens after perihelion.
The point of maximum thermal and gravitational stress from the sun.
3I/Atlas began to fall apart while it was still approaching the sun, at a distance where our own comets are perfectly stable.
It was as if it was made of something weaker.
Or as if something else was tearing it apart from the inside.
Clue number 3, the alien chemistry. As it broke, it released its internal gases, its pristine, ancient materials.
Our telescopes analyzed their chemical fingerprints. The results were baffling.
Comets from our solar system, like Halley's or Hale-Bopp,
are water-rich.
Water ice is their dominant component. Atlas was extremely rich in carbon monoxide, CO, and its coma was massive.
This chemical signature suggests it formed in a very, very cold ring star system.
This alien chemistry could also explain why it disintegrated.
Carbon monoxide ice vaporizes at a much lower temperature than water ice.
It was never built to survive a journey this close to a star like our sun.
It was a visitor from a far colder place.
Melting before our eyes.
But this is where the mystery deepens.
Clue number 4, the impossible dust. This is, perhaps, the most important clue of all.
It's not just about the gas, it's about the dust.
Astronomers used a technique called polarimetry. It measures how sunlight scatters off the dust grains in the comet's coma. This, in turn, reveals the structure of the dust itself. Every comet in our solar system,
Every single one we have ever measured,
shows positive polarization.
Three ice, extreme negative polarization.
This is complex, but it's crucial. Let's build the 3D model. Feature: positive polarization means light scatters in many different directions.
Advantage: this happens because our cometary dust is made of complex, fluffy aggregates, like tiny, intricate snowflakes.
Negative polarization means light is scattering in a much more uniform, parallel way. Advantage: this implies the dust grains are not complex and fluffy.
It means the dust of Three Eyes Atlas was made of monomers.
This wasn't just alien chemistry. This was alien physics. A dust structure our models could not explain.
A fundamentally different structure.
Clue number 5, the nucleus.
So, we have a comet that's too bright. That breaks apart too soon.
Is made of exotic ices.
And is shedding impossible dust. What about its heart? What about the nucleus itself? Based on the coma's massive brightness, the nucleus should have been large. Several kilometers across, at least. But as the dust cloud expanded and faded,
Astronomers looked for the central core, And they found nothing. Or rather, they found fragments no larger than a few hundred meters.
The heart of the comet was tiny. It was a sheep in wolf's clothing, a tiny, fragile body.
This rewrote the entire event.
It didn't just disintegrate. It evaporated. Clue number 6, the TESS shutdown.
The test satellite, NASA's Planet Hunter, caught a crucial moment.
It watched 3I/Atlas continuously for 26 days. It saw the initial 100-fold brightening, and then it saw the coma switch off.
The data was so clean, it was chilling.
The comet brightened. The nucleus must have fragmented. And then,
It wasn't a slow death.
It was an instantaneous shutdown. As if a switch was thrown.
clue number 7, the violent spin.
This leads to the final clue, the why. What caused this catastrophic, sudden failure? The lead hypothesis is rotational breakup.
The idea that the comet was spinning so fast, it tore itself apart from centrifugal force. This can happen as the sun heats the ice.
It creates jets of gas, which can spin the nucleus up.
Faster and faster until it fails.
But the forces required would mean the nucleus was already incredibly fragile, barely holding itself together.
A suicidal spin activated by our sun's gentle heat. This is the prevailing theory.
But it still doesn't fully explain the dust. It still doesn't fully explain the polarization. We have 7 clues.
An impossible orbit. A deceptive brightness. A premature death. Exotic chemistry.
Alien dust. A missing core.
And a violent final spin.
Individually, each clue is a puzzle. Together, they paint a portrait of an object that is fundamentally and completely alien.
The comet was dead.
Its core was gone, evaporated into a diffuse cloud of alien dust and gas.
The investigation, it seemed, was over before it truly began.
But the laws of physics are relentless.
That cloud of debris, the comet's ghost, was still traveling.
It was still moving on that same, impossible hyperbolic trajectory.
And we had assets in the field. This is the climax of the hunt. In late May 2020, mission controllers for the European Space Agency's Solar Orbiter, a probe designed to study the Sun, ran an analysis of their trajectory. By a complete, beautiful coincidence, Solar Orbiter was scheduled to fly direct. We didn't just get to see the alien. We got to touch it. Its instruments were turned on. They tasted the material. The data confirmed it. A chemistry untethered from our own. A structure that was collapsing under our sun's heat. This was our first point of contact.
But it wasn't our last.
At the same time, 140 million miles away, a robot built for geology was sitting on the surface of Mars. The Perseverance rover. In an unprecedented act of interstellar astronomy, mission controllers gave it a new command. Stop looking down at the rocks. On June 22nd, 2020, Perseverance pointed its...
It was a grainy, unremarkable image.
But its significance is profound. It was the first time in human history that an object from another star system was photographed from the surface of another world. A robot on Mars. Taking a picture of a dead comet from an alien sun. This was the final observation, the last visual evidence. The hunt was over.
All that was left was the data.
And so, it is gone.
A fleeting messenger that survived a journey of millions of years.
Only to be annihilated by the gentle warmth of our own star. The investigation is closed. The evidence is collected. What is the final verdict? This is the difficult and beautiful part of science. We now know with certainty that objects in other star systems are not necessarily like our own. Our solar system, with its water-rich comets,
may not be the standard. It may be the exception.
The clue of the exotic ices, the carbon monoxide.
Tells us that its home was a far colder, darker place.
A different structure to the universe's building blocks.
We have never seen it before.
The theories remain open. Was it a tiny fragment of a Pluto-like object from another system? Was it a truly pristine comet, formed so far out that it never underwent the processing our own comets did? The data doesn't favor one single answer. The only definitive conclusion is that the galaxy is infinitely more diverse. Oumuamua was a strange rock. Tuai-Baish Borisov was familiar.
3 Eyes/Atlas was something else entirely. A ghost. A fragile messenger made of impossible dust.
The case file remains open.
We have presented the 7 key clues.
We have shown you the 3D models of its orbit, its chemistry, and its dust.
Now, the investigation turns to you.